All right. What we're going to start looking at is how we can do some things with some graphs as far as moving those graphs around, or maybe scaling those graphs, making them wider, making them narrower. And the graph we're going to focus on initially is going to be this graph here. If I ask you what's the equation of this graph here, what am I looking at? Got a parabola of it. What's that equation going to look like? Right. So we're going to start with the equation y equals x squared. This is what we'll refer to as the parent graph of a quadratic. The parent graph being this is where all the other graphs are going to start. All right, well, with that parent graph, there's some key pieces that we want to pay attention to. What's probably the most important point on a parabola? Yeah, the vertex. Where's it at right now? 0, 0. Okay, so we're going to pay attention to where the vertex is located when we look at different parabolas. For a parent graph, that's going to be at the origin. It's going to be at 0, 0. Something else that we're going to look at is what we'll call the orientation of the graph. Well, the orientation is essentially which direction is it opening? Is it opening upward? Is it opening downward? Well, obviously, for our parent graph, that's going to be opening upward. So that's something else that we'll pay attention to. The third thing that we'll pay attention to is, have I taken this original parent graph and done one of two things to it? Have I vertically stretched it, or have I vertically compressed it? So let's think about what that means and what it would look like as far as the graph is concerned. If I take this rubber band here and I stretch it vertically, it means I'm going to stretch it this direction. What happens to it? Breaks. What happens if I take this rubber band and stretch it vertically? Hopefully not break it. Does it get wider or narrower? Narrower, right. So if I'm going to stretch this parabola vertically, if I'm going to stretch it this direction, I should have a parabola that now gets narrower than what it was before. Versus if I compress it, if I push it down, well, now when I push it down, that parabola is going to get wider than it was before. So if I'm asking this question, have I vertically stretched it, what I'm really looking for is, have I made it narrower than what it was before? Versus if I compressed it, what I'm looking at is, have I made it wider than it was originally? Okay? Well, what you're going to do with your investigation today is you're going to try to figure out, how can I take this equation, make some adjustments to that equation to get some of these results. In other words, one of the things you're going to be asked to do is, all right, well, how can I change this equation to where my graph may move down a certain amount? Or how can I change that equation to make it go to the left, or make it go to the right? How can I change my equation to where the new graph would be narrower than what it was before, or wider than what it was before? Maybe I'm trying to take this equation, instead of opening upward, how do I make it open downward? All right, so you're going to be asked to make some changes to the equation in order to get some desired results. One thing you cannot change, though, on your equation is the exponent. So your exponent's always going to be 2, no matter what equation you end up making. All right, so kind of keep that in mind. All right, so I'm going to have you scoot into your groups. So I'm going to give you a sheet here, and it's going to have a number of situations that you're going to have you try to do. So go ahead and move into your groups. So kind of explain what you're going to try to be doing. And again, your graphic calculator will be helpful.
Yeah.
All right, so you're going to follow the different parts here. Other than, first of all, it says graph the parabola y equals x squared. Well, we've already done that. But all these different problems they ask you to do, you're going to start back over with y equals x squared. So any change they ask you to make, that change is going to be made to y equals x squared. Okay? But some of the things they ask you to do, like on part A, they ask you to change it to make it stretch vertically. So remember, that makes it narrower. The second one, they want you to compress it vertically, so make it wider, and so on. I would keep track of what you've tried, because some of it's going to be some trial and error. Keep track of what you've tried, because maybe you try to do one thing and it actually takes care of something that you need to do later on. All right, so keep track of your mistakes as well as your successes on this. All right, so it's like I said, a little bit of guessing, checking on some things. Compare what you come up with your group members.
Yeah. It was bigger.
Second equation, I did 2x. So you have to stretch.
Yeah.
So I think you do.
Either like half of X. Open downward, it's just negative.
Yeah. What do you think to make it open down? Literally all you're doing is like having y.
So then it's. I think it's X squared.
What you would do for this one, you would do y way, x squared minus y.
No. It's minus this.
You have to do
Well, it's the vertex, right?
up with one is
Makes it like,
so it would be
if you make it minus 3x, it just makes it.
I'm gonna make it up now. Make it up and down. Make it up and down with y. To make it narrow,
oh, right.
How do you guys know? I do that, but sometimes I use like because sometimes I'll do that, sometimes I go like that.
Yeah, I just don't, I'm actually not like.
Really? That's like that. Or is it how much like that?
No, not And the first one, yeah.
So? Let's go multiple. I had a murder on my phone. That was
When you think about moving and think about where the vertex is located. It started in the origin, where is it at now? So you,
I don't know, it's not like.
And then I don't know.
Yeah, you just want to smile. Somebody's wondering about me, it's like,
I tried to.
It's doing something like that.
Okay, I didn't think so.
Trying to do your eyes.
Yeah.
That's one tough one.
You should have already done
Something to maybe think
No, I
about.
think you got out of
Left to right.
Or someone, no, that was, someone got out of it.
Right. Somehow you gotta deal with the X. Change it.
Sometimes
Make it move left.
Oh, wait.
Somehow you gotta make sure that deals with the X before it deals with the Y.
But they call it like surprise. Yeah, his.
Yeah, I think that.
I don't listen to that.
It's like my first song ever.
You don't have it's good. Mama cries.
Anything below, anything.
You don't like that or?
Yeah.
No, they look like inject something.
I can make a random.
You don't think they get, you know? Subtract 4.
Yeah, I got it. So you like put like so like X minus 3.
I don't listen to that. Well, Sue sounds like the teacher makes us too comfortable. I mean, this isn't that good. This is what my baby is.
Is that what you're trying
They're
to say?
all in the.
Yeah.
Yeah, because I mean, that's just talking about I just because he did. Because he was so jokes and jokes were gonna kill him. These are our friends. You like have like a bottle of these pills and you like.
Yeah, but.
You would never do it. You did like ecstasy and you said you did like.
I know sometimes on like the longer.
You get like a seizure after
You figured out how to really play? All right.
Yeah, you're not allowed to have drugs.
now.
Just flip it wrong.
Yeah. Oh, so you put whatever extra.
I doubt it. Wait, what kind of condition you guys
You don't know.
Somehow we do it yourself? What? You do it like yesterday?
That just looks like that.
When I was young, it's like 2 seconds. Yeah, we did. You never done costume?
I know, but
Yeah.
There you go.
Somehow you gotta avoid.
You like go to the hat?
Yeah.
Correct. Do you have to run that? Or do you don't go back to that?
Yeah.
Some way that I get it.
Here's the hat. You run to the hat. You stop.
Some way I can deal with the.
You stop, you start, you drop the in. You stop there.
I don't remember everything.
Oh, where was
It was like during the summer.
Oh.
I don't remember during the summer.
Oh, yeah.
This is the field. Look, this is the field. You run to the hash. You run fast.
Oh,
You run to this hash.
yes,
You run
yes,
fast.
yes.
You run to the full field.
Yes, except it was.
Were you not there? Oh my God, I forgot you were there.
It's not
It
It's
was like the same.
It's awful.
But the way we do our watch that is, we just jog, then you expect to part of action jog,
She's still making.
and then you have to all over. Now, I see that. You just run, or you just run behind you, or you just run behind them?
Sometimes.
Swear.
Well, I don't know, we just often we just make it run through.
We have really fast people that cannot run very fast. Myself included.
Yes.
Sometimes.
Oh, I think maybe it's gonna be I just have to go over the next step. I'm a successor here, but too.
Oh, wow, that's.
Yeah, that gives me like no time to get ready.
Yeah, I'm sorry, they're not, actually, I'm not first time here. There's a big, like,
I would be in like, what is that?
Let's go back to.
So.
Some stuff, like, I think it's been a jump multiple times. I only have about You have some Kanye?
Somehow we're gonna. See for the X and square.
When TikTok's getting taken off the app store.
Oh.
That's what that.
All right, guys, in your groups, I don't know if we've done this yet or not. I like to do number 10s in your group, which is a fancy way of saying number off in your group. Okay, so somebody's number 1, somebody's number 2, and so on. Oh, have we done that?
All these do.
Sure.
Yeah, see, I was unless you wanna be one.
All right, person number one in each group, this is what you're gonna do. In the back, I have all the situations that you were trying to look at. You're gonna go back there and you're gonna write the equation your group came up with for each instance. Even if the equation's already written up there, the one you used, you're gonna write it again, okay? So I should have 1, 2, 3, 4, 5, 6 equations for each one up there, okay? When you're back there, don't be on top of each other, kind of give yourself some space. But there's markers back there. I want all the equations you came up with for each part, okay? All right, go ahead and start heading back there.
Hey, you number one.
No.
But did you see this I was watching iCar.
Oh, I
Or I wasn't really watching. I had no one I was doing it. There's exciting. Wait, what song is it? Who's it by?
Other guy.
There's a song called Isis. It's by the Launch.
Try to write it so we can read it, please, back here.
It's a child. It's a player. They're just cute. Can you find me that thing? My nephew at least is cute, but my niece is just so. Yeah, my brother is like 2. Or he's only like half brother, he's got like 2. He's 30. One, yeah, like. He drives the bus for city transportation for Kokomo, which is 2 hours north of here. He went to golf school. It doesn't, it's kind of golf school. He had been I mean, I don't know if he, yeah, maybe it's job. He's still looking on the town. No, the warehouse pays good, and I know I asked somebody. Because it's a bunch of physical. I mean, it's not like super.
My oldest sibling.
Okay, kind of focus on the back there. And what I want you to try to look at is, first of all, which equations did everybody get the exact same equation, and did it have to be that way? In other words, even if all 6 groups had the same one, did it have to be that same one? For the ones that we got different ones, should that have happened? Should we have all got the same, or was it okay that we got different ones? Also, especially on the last one, there's different ways that people had written there, so let's see if that was okay to do that. All right, so just kind of take a look at them first, and then we'll kind of see what you think about some of those questions. What about the ones that everybody got the exact same equation? Looks like this one looking downward, this one, and this one. Everybody got the exact same. Did it have to be that way? Let's start with the opening downward. Any other way to make it open downward?
Yeah.
How else could I make it open downward? Take a negative number where? So if I put a -2 and squared it, that would make it open downward. Right. Now that may do extra things to it also though, right? But you're right, that would still make it open downward. If I only want it to open downward and not do anything else, in other words, not any wider or any thinner than it was before, is there anything else I can do other than have the negative number? No. Okay, because even though it's not written there, it's really -1. 1. Okay. So that was the only way we could do that. Is there any other way to make it open or move 5 units down? No, we had to square it like normal and then take 5 away from it. So that was the only way to do that. Any other way we could have done this? Notice what everybody did. You did x -3 in parentheses, and then you squared that. Why would that make it move to the right? Seems like if you, here we subtracted, that made it move down. It seems like if I subtract here, it can make it move to the left. Any idea?
Oh, you're spreading it to the negative being squared. Oh, that whole expression being squared.
Right.
So it's gonna.
Okay, but wouldn't this end up being possible? Wouldn't that move it to the right? No. Okay, that's part of it too, is the fact that we put in parentheses to make sure the x was dealt with first. We said we want to move it on the x-axis, correct? Okay, so that is part of it.
It's like, it has to be, it kind of applies to the y. So like whenever you're like solving an equation, you like have to add or subtract both sides. So, like it's kind of like doing like y plus or -3. So.
I think I understand what you're saying. Let's see if this helps a little bit. If I focus on the vertex, where would the vertex be in this situation now? 3, 0, right? Or in other words, x is equal to 3, y is equal to 0. So I need whatever equation I have. If I were to plug 3 in for x, I got to make sure that y is equal to 0. Well, if I plug 3 in for x, the only way I can get back down to 0 is to subtract 3. So that's why we have, in this case, 3, but 3 minus 3 would be 0. 0 squared would give me the 0 that I wanted for 1. Okay, so that's why we're doing the opposite on that one. Versus this one, if I wanted the vertex to drop down 5, it's now at 0, -5. Which means when I plug 0 in for x, I wouldn't end up with y being -5. That's why I squared the 0 first, and then I subtracted 5. That's why I got it. All right. Sometimes you can be a little bit confused on that. All right, so those are the only ways that we could do those. Stretching vertically. Had some different answers for this one: 4x squared, 2x squared, 3x squared. So we had different things that would work here. But the 2, the 4, the 3, they all did have something in common. What was true about all those?
They were all equal words.
Yeah. And we're going to call this number out in front. We're going to give it the variable of a. But all these were larger than 1. So if I have an a value bigger than 1, we know it's going to make it narrower. Now, why is it making it narrower? If I think about my original graph here, if I do x squared and then I turn around and multiply by 4, what used to be here at, say, 1, 1 is now at 1, 4. So it's increased at a faster rate. We used to have -1, 1. Now we're at -1, 4. And that's why it's making that graph thinner than what it was before. So if I have an a value bigger than 1, it's going to stretch it vertically. what's my rule for this one? Am I correct? Yeah, so it has to be less than 1 for sure, but it can't be less than 1 forever. So I'm pushing it down, I'm pushing it down. What would happen if I got to 0? It'd be a line, right? It'd just be the x-axis. So I can't go 0, I gotta stay between 0 and 1. What if I kept pushing it past 1? What if I went to the negatives? Here, yeah. If I push it down to 0, it's flat. If I keep pushing it down, now it's negative. And it does what we said was going to happen on C. It's going to open down. That's why we can do that. All right, so our A value is between 0 and 1. We're compressing. If it's greater than 1, we're stretching. So if I put those two things together here for part F, moving 3 units to the left, we said really that should be x plus 3 squared. Stretching vertically, as long as I have a value bigger than 1, I'm in good shape. So it looks like all these that chose this direction were in good shape. Now, does that mean this is not correct? No, not necessarily, because we could do some factoring out of this. If I really multiply this out and then I factored it, I'd be able to pull out a factor that was bigger than 1, and I would have been okay here. In fact, if we look at these two, get that factor of 2. All right, so that's a variation. Probably a better way of writing it might be something like this. Well, here's our goal for this chapter. We're going to throw the calculators out. I'm going to be able to give you an equation, and you're going to be able to sketch it for me. For instance, if I gave you this equation, and I said, sketch that parabola without using your graphing calculator. Well, the things that we want to have in our sketch, we want to have the vertex in the correct location. We want to have the correct orientation. Is it opening up? Is it opening down? And we'd want to have whether that has been stretched vertically or whether it's been compressed vertically. So let's see if we can answer some of those questions here.
The vertex is 1, 4.
Good. The vertex on this one would be at the point 1, 4, because we moved it to the right 1. After we squared it, we added 4, so we moved it up 4. So I could actually start my sketch there. I would make my vertex at 1, 4. Okay? What would the orientation be? Would it be opening upward or opening downward on this one? Where am I going to look for that? Nope. Yeah, and so that tells me it's opening upward because it was positive. So I'll keep that in mind. Lastly, is it being stretched or is it being compressed? Or sometimes it may not be either one. It may just be at the normal shape. What about on this one? What have we done? Compressed because of the 1/3. So this one would be compressed. So if I were making a sketch, it doesn't have to be exact, but I'd make a parabola that's opening upward that is wider than what we had before. So that would be a sketch without using any technology. So I'm going to give you a couple equations here. I'm going to see if you can sketch these without using your graphing calculator. Once you've sketched it, then type it into your calculator and see if you've actually made one that looks like what you thought it was going to look like. So here are the two equations I want you to try to sketch. Try to stretch those two, or sketch those two. Make sure that you label any key points, which would be the vertex, and then Make sure your shape is correct. Make sure that you label where the vertex is at clearly. Where's our vertex on this first one at? What's the x minus 5 and then being squared? Tell me, how's it been shifted, Joe? Good. It's going to be shifted 5 to the right. Now, with your sketches, it's a lot of you use graph paper, and that's fine. But technically, for a sketch, we don't have to have graph paper. However, you need to make sure that you clearly mark where it's at, whether that be with tick marks or labeling it as, in this case, 5, 0. But clearly show where that vertex is located. All right, is this going to open up or down? Down because the negative, stretched or compressed? Compressed. So it's going to be a little bit wider. And again, we're just sketching, so we don't know exactly what it's looking like, but it's going to be a little wider than normal opening now. All right, where's our vertex on the second one? Located. So this group up here for vertex on the second one. -2, -3, because it was shifted to the left 2 and down 3. Okay, is it going to open up or down? Up because of +4. Stretched or compressed? Stretched because that +4 was greater than 1. And so it's a little thinner than open. So we should be able to eventually at least be able to sketch these without using our graphing calculators. Now, all these equations, or most of these equations that you guys came up with and I gave you here, they were fairly quick to graph because they're in what we refer to as graphing form. Or sometimes you hear it called vertex form. So if an equation's in graphing form, here's the general equation that we're going to use. It's going to be y equals a, I mentioned a before, that's the coefficient out in front, times x minus h squared plus k. So if they ever talk about graphing form, that's the general graphing form, or sometimes you'll hear it called the vertex form. And so when it's in this form, the nice thing about it is it's easy to graph. That's why they call it graphing form, because I can pick out the vertex quickly. I know which direction it's opening. I know whether it's stretched or compressed. Unfortunately, it's not always going to be in graphing form. We actually have two other forms that we'll write our quadratics in. One of those other two forms is what's referred to as standard form. Standard form looks like this. Y equals ax squared plus bx plus c. So notice standard form doesn't have any parentheses. No parentheses in standard form. Y is still by itself, just like in a graphing form or vertex form. Well, when it's in vertex form, it's easy to find the vertex right away. That's why they call it that. If I look at the standard form, though, if I gave you the equation, say, y equals 3x squared plus 8x minus 1, do you know where the vertex is right away by just looking at it? No, I don't really have any shifting that I can pick out just by looking at it here. So standard form's not as nice for graphing as what graphing form is. Now, it doesn't mean that standard form's useless. We can still find a little bit of information about it. For instance, there is one thing on here that is useful as far as the graph's concerned, or actually a couple things. But what would be special about the C value there? We're looking at that constant. Y-intercept. So I can pick out the y-intercept because the C value would be the y-intercept. Notice it does have an A value just like the graphing form does. So it would still tell me whether it's stretched or compressed or whether it's opening up or down. But I don't have that vertex to lean on like I do here. We've used this for something else also. What have we used this before that didn't deal with the graph? What have we used A's, B's, and C's before? Yeah, quadratic formula. So it is useful for having it in that form for quadratic formula. Just the graph itself is not very useful. So because this is not useful for the graph, sometimes we want to go from standard form to our graphing form. So we got to have a method to go from standard form to graphing form. And that's what we're going to try to figure out next, is how do I take something that's in standard form and get it into graphing form. So let's say I gave you this equation, y equals 2x squared plus 4x minus 30. And my goal is eventually to be able to sketch this, but I've decided in order to sketch it, I need to be able to get it in a graphing form, because then I can pick out all the stuff I need. Well, it's not quite graphing form, but we have done a little bit with this to create some parentheses in the past. What if I ask you to factor this equation? Well, do all those terms have anything in common? Because I always want to start with that. Yeah, it's got a 2. So I'm going to pull a 2 out. When I do that, I'm going to be left with this. So still not graphing form, but at least I have some parentheses in there. Can I keep going? Can I factor the x squared plus 2x minus 15? Can I multiply to get negative 15 and add to get 2? Yeah. What can I multiply to get 15 but add to get 2?
Plus 5 minus
Plus 5 and minus 3. Okay, so I've gotten to here, which actually is a third way that I can write the quadratic. I can also write it in factor form. Or y equals, usually you'll see r's and s's, it doesn't really matter what variable's there, but a times x minus r times x minus s. So notice it has an a just like the other two did. So as far as the graph, that 2 does tell me something. It tells me it opens up. It tells me it's stretched. Did these two things tell me anything? The x plus 5 and the x minus 3? Could they help me at all on the graph?
Who they give you the vertex?
Not the vertex, but it does give me something.
The intercept.
Yeah, the intercept. So I could find the x-intercepts in my graph because that would be when y equals 0 and x plus 5 would equal 0 at negative 5. So I know that. X minus 3 would be 0 at positive 3. So I do know those two things. Like I said, I know it opens up and I know it's stretched, but somehow I need to know where that vertex is down here. So how can I figure out where that's at?
Can we find like the center, maybe which way the two lines are, like how it goes on? And
Good.
then plugging it into the
Yeah, good, because we know that if those are the two x-intercepts, if we're really making a parabola, it should be symmetric. It should be able to fold it over. In other words, I should be able to take this point, fold it over on that one. Well, where I fold it should be a line that contains that vertex. So halfway in between these 2 points, the point negative 5 and 3, should be the x value for my vertex. Well, to find the halfway point, remember last year in geometry, you did the midpoint formula, where you added those two, divided by 2. So negative 5 plus 3 is negative 2. Divided by 2 tells me my x value is at negative 1. So somewhere along this line of x equals negative 1, my vertex is on. Like Ben said, the way I can figure out what the y value is plug negative 1 and see what my y value is. I could go back to this if I wanted to. I could go into this if I wanted to. Let's say I did put it in here. Well, negative 1 plus 5 would be 4. Negative 1 minus 3 would be negative 4. So my y value is going to be 8 times negative 4, or negative 32. So my y value for my vertex would be at negative 32. So down in here. And then I can make my graph from there. Now, I still haven't written it in factoring form or in graphing form quite yet, but I have the information that I could do that. So my graphing form of this equation would be y equals 2, because that was our a value, x plus 1 squared, because the vertex was at negative 1 for x, minus 32, because that was our y value. And so that standard form, written in graphing form, would be that. Now, that was a little bit of a more involved problem, but the idea of finding your x-intercepts, doing the average of those two, and then plugging that x value in to find our y value is one of the methods that we're going to use. And the book just calls that the averaging of the intercepts method. So I'm going to have you try one where you're trying to figure out where the vertex is located, and you're going to use that then to rewrite it into our graphing form by using that averaging of the x-intercepts. So here's the equation that I want you to use. X squared plus 3x minus 10. See if you can rewrite that one into graphing form by using our averaging of the x-intercepts. Again, start out by thinking about factoring it first, find those x-intercepts. So if I use the two x-intercepts of -5 and +2, you should have found the vertex is at -1.5, -12.25. Unless I made a mistake, you might disagree with me. I make mistakes sometimes. So how am I going to fill in my equation then? We'll go inside the parentheses here. I'm going to write it in graphic form. X plus 1.5, or if you wrote it as 3/2, that'd be fine. Okay, so I got x plus 1.5 squared, and then what? Minus 12.25. What's our a value here? 1. Yeah, it's just 1, so I don't have to worry about writing anything. Okay. So that means it wasn't stretched or constrained. So the averaging of the x-intercepts is one method that we can use to go from standard form into our graphing form. Next week, we'll look at an alternate way of attacking that. That might save us a little bit of work and a little bit of headache on it. But right now, we're going to use this to get us started. All right, well, we're going to follow up on that next week. But I want to give you some time to work on your assignment that's due for Tuesday, fairly short assignment. But I'd like you to do these problems here, 35 through 41 for Tuesday. We've got about 14 minutes now. We can get started and maybe get a basic chunk of that done. I'll look through the homework that you hopefully turned in today, and we'll see what questions we need to hit next week with those. Wrong chapter, sorry, chapter 2, not 3. It's been flat. Sorry. Yeah, chapter 2, make sure you're in the correct chapter, chapter 2.
Yes, sir.
But let's use your time. Let's not just sit here for 13 minutes. Use your time, please.
It's like there's a bunch of black boxes. It's like super still. I've never seen it.